The printer's all assembled and wired up. Welcome to Hack a Week. Last video I left off ready to do the wiring and a little bit of calibration, and well, there it is, it's all done. So let's go backwards and review a little of what it took to get to this point. Yep, we got electronic stuff to put in here today. We got controller boards. Ooh. We've got the LCD board. Sexy. LCD. I'm not sure how it's backlit, but it just looks cool already. I like the knob. Okay, so let's start with the controller board, getting it mounted right there. Our little controller board is going to mount right here on this steel plate. There are 4 risers already welded to this plate, and there's a USB port right here. It needs to point towards the back of the machine. We're going to put one right up against there. We're going to grab a 3mm by 5mm long screw. Get one of these started. Here's another reason right here for one of those ball end Allens. It's an odd angle to get at. Snug up the screws, not too tight. It's only holding a circuit board in. Next up, power supply. Looks kind of like a power supply for a computer, but it's not. It's a dedicated one just for this unit. Let's turn this around so you can see where this is going to mount. It's going to mount right here on this big plate. Super important step here. See what that says right there? Well, a lot of people have put this kit together and they've left this in the 220 volt position, and then the stepper motors run all weird and they complain and they write bad reviews on Amazon because they simply didn't understand. Right now I'm going to check this one. Over this way is supposed to be for 110. That's what we use here in America. 220 is most of the rest of the world. Oh, look at that. It was in the 220 setting because it's made in China. So make sure you put that to 110 volt. Very, very important. Very, very, very important. Same kind of mounting hardware here, M3 by 5mm. There's 4 holes. The terminals here need to point down. Simple as that. The holes are here in the corners, right there, 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 and there. So you look ahead of time, and there's one. And then we'll tighten them up. Most of this kind of hardware, I just put 3 fingers on an Allen wrench and push till my fingers squish a little. Now we got the LCD mount. Here we have the frame that it mounts in, and I've got 2 M5 by 8s in there with T-nuts on them. We're going to mount that right up on top. Drop the T-nuts into the slot and tighten them up. Now we'll mount the LCD unit to the frame. First we need to unwrap the ribbon cables. 4 M3 by 5s hold this in. The knob goes over on that side. We'll spin this around so you can see it. And there's just 1 screw in each corner. Now we'll get the filament holder. 2 braces, they go up here, held in place by a M5 bolt with a T-nut in it. Put the bracket facing away from each other toward the outboard sides of the machine. I'm going to use my other Allen right here. This is kind of what you get for instructions. You get basically this. So each one left and right hand. We move on to the next bit, and just got to be far enough apart for that span to go whatever the dimension of that bolt is and whatever the width of the spool is. Pretty simple. So if I just do a quickie here, fit, you can see that that's got to be a little bit further. I would think it'd be better to put it over this way because it's making a loop coming into here, and the longer that loops are, the smoother they usually run. So let's move this all the way over. Loosen this one back up. Bring that down here and see about how wide we want to be here. Okay, about there. Get them nice and perpendicular and tighten them up. Let's drop some all thread in there. And then I've got some 8mm nuts that I can put on there. There we go. So it looks like this just rubs against there, and that's pretty much how that hangs on this here machine, huh? Well, I think maybe I'll be downloading a little spindle for that and 3D printing it soon to solve that problem. Ha ha! Well, now time for the wiring, and that's pretty much all they give you for the wiring is what you see right there. Let's take a little closer look. It's nice and clear, but that's it. You gotta just follow a diagram and pay attention, and it should all be good. So here we go. Take a look at where everybody did the loops, because this has to move up and down. So this may be good coming over the top here. Over here on the power supply side, this little window just flips up that covers up the terminals, and it's V plus on the first three and then common on the second three, and common of course is negative. So we can just take the first one here and we'll put our positive wire on it. And we can go down to the first common terminal. Loosen it up so we can get the wire in there. Make sure you put it under the little washer. Now we have the power connected. The hotbed. The hotbed gets just a standard computer peripheral plug. How about that? And the positives are, let's see, it goes positive and negative, and that's pretty much it. There's the label on the bottom, bed positive, bed negative, and NTC. So the heat bed over here is right there. I need a little more wire on this, so if I just grab the end and pull, since it's already soldered, I'll give myself a little bit longer piece to work with. And the black one. You know what, I'm going to just take a crack at the idea that the TC and that NTC stands for temperature control, maybe, and there is a tiny little thermistor down there, so this probably connects to that. And if I look on the diagram off camera here, it's supposed to go in this second terminal right there. If we flip the printer over, you can see we've got the Z-axis motors here. So we put one of these on one motor, and the other one can run across to this motor. Actually, the shorter pigtail goes on the motor, then this one terminates up in the control board. I'm going to tidy this wire up with a few wraps of just some electrical tape. So I just put a little tape around it all the way across and brought it over here. Took the extra that I had and put it in there in a nice little bundle. So that one page I was having trouble with a few videos back was about a little proximity sensor that goes on here. I didn't find it until just now, and I got to the point where I went, hey, there's something missing that I'm supposed to be plugging in here. That goes on the back on this linear bearing, and it's held on with two M3x20 screws and nuts. It's going to be a little tricky to put on now because I've got the entire extruder in there and assembled, so I don't know if I can actually even get the screws to get in there. Move the extruder for now and we can put this on. Silly me. So the instructions said to put an M3 by 20 in there to hold that sensor in place, but they're not long enough to go all the way through that. But an M4 is what that hole right there is tapped for. So if I just put an M4 bolt in there, then there we go. I think that was I guess that was a little error on their part, or they changed their mind later. I don't know. But anyway, it takes care of that. Funny thing with wire harnesses, there's always a better way to run the thing or route it or do it or whatever. It's always kind of a play around with it till you get it all loomed up and all wrapped up and then call it done. So we've got that sensor line coming across now, and I can take this stuff and take up a little bit of slack, slide it down onto this wire a little more, make things look pretty. And last but not least, we can plug that end stop in for the extruder right there on that very last slot. Ladies and gentlemen, there it is from HIC Technologies. It's the 3DP-11 printer. Cool. That's kind of funny that I'm getting the back voltage from that stepper motor lighting up that LCD. That's a little strange, don't you think? Wow. No power switch on this thing. You just plug it in and it boots up and it's on. I think a power switch would be a good idea. And my favorite part is peeling off the protective plastic covering. I love doing that. Don't you love doing that? So let's bring the Z-axis down by hand until it almost touches the bed with the print nozzle. So there's a close-up of where I'm at with the print nozzle. I have a palette knife here that I bought. They call it a 3D print removal tool, but basically it's an artist palette knife. And it's not very thick on the end. It's maybe, if I had to guess, 20 thousandths or so. But look at that, where we can barely put that underneath there. Just about like that. Or you can just pass it under the nozzle. That's how close you want that. Okay, now what I want to do is level out the bed, which is done with the 4 screws that are in each corner and the wing nuts. And I've turned them down ahead of time until they are all clearing the rail here by about 5 or 6 millimeters. So let's move the bed like this, and we're going to move the x-axis all the way to a corner. Get it in a corner and put your palette knife in there and see where you're at. I can see right here, I'm just touching the bed. If I move the bed to this end, it's almost touching the bed. I can't quite get the knife in there. Let's go back to the middle. I can get the knife in. We'll go back to this corner over here, and it looks pretty low actually. If I go to this corner, also looks a little low, but it looks pretty equal from there to there. So what we'll do is lower this side just a little. So I'm going to hold the wing nut underneath and turn this screw in just about half a turn. and let's check it again. I'll just move the x-axis over, and that's a little better. That's not too bad. Let's go just a little more on this one. That one's not bad. So let's turn these down just a little more. Check it again. This is really, really important that you get this right. The bed being level has a lot to do with how well the first layer that gets printed sticks to the bed, which is super important, because if you don't get a good adhesion on that first layer, you can ruin the rest of the print. Let's go back to this side and check it again. This is what you're going to do, is just keep working your way from one corner to another until you get them all about the same. Okay, we're looking pretty good there. Well, let's raise this back up to about here. And let's take a look at the limit switch that got installed over here. Over here, mounted to this rail, mounted with the screws coming in from this side, is another one of those little limit switches. This is in case the program crashes and decides to go too far down on the Z-axis. This will stop the motor. So the first thing we're going to do before we adjust that is to do a function that's called auto home, and we'll do that right now. So we've got the print head up above the bed, and up here on the control board we're going to push the button, and that's going to bring up all of this stuff. We're going to go to the prepare menu, rotate the knob, push the button. Now we're in the prepare menu, and we'll push auto home. Push the button, and what it's going to do is find where it's at. Go to the limit switch, the other one goes to the limit switch, and it comes down, 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 down off the board, you can see. Then it comes over to the middle, and it's going to park itself. Now let's take a look at where it parked and how far it is off from the deck. Looks like I've got room to get that knife through there. We're going to coat this with some masking tape, which will help keep the plastic from sticking to the aluminum. We don't want to print directly on the aluminum. And what we'll do is cover it with tape, and we'll check this again. What you want is that nozzle to be close enough so that when it does that first layer, it actually makes a good contact with the bed and adheres to it. So the printer came with this bit of 2-inch masking tape. It's pretty thin stuff. I guess just about any plain masking tape would work. We're going to cover the bed with it. Now, I don't plan on printing all the way out to the edges, so I think what I'll do is start with a strip right about in the middle, and then just work my way towards the edge of each end. Now, if I was going to print some really big stuff, I guess I could cover the entire board. But most of the printing I'm going to do will probably happen right around this zone here. Try to get the gaps minimal. You can trim the edges, or you can just leave them like that. You'll be replacing that tape often, so make sure it's pressed down really well. And let's plug the machine back in, and we'll go to the menu here for auto home one more time. Prepare menu, auto home, and we'll let it do its thing and see what kind of clearance we have. Okay, we are at the home position. Let's see what we've got for some clearance here. Not bad. I can just get the knife in there, so that's about right. Now, if you need to change that clearance, that proximity sensor on the back I had to mount up is what you adjust. Let me show you that. Well, right here is the proximity sensor for the whole print head. You see that red light that's on right now? If I rotate the Z-axis up, see that light goes out? As soon as the light comes on, that means that it has detected a surface below it. So by moving that up and down, by loosening up these two screws right here, moving it where you need to, and then tightening it, you will adjust where this ends up at the home position. So in other words, if you do the home position and it ends up too high, then what you need to do is raise the sensor up a little bit so that it will come down further until it triggers it and the little red light comes on. You may have to do that several times before you get it right. Right there's the limit switch. I have it adjusted already, and the way it should be adjusted is so that when it's at the home position, it is not triggering the switch. Now if I turn this lead screw right here just a little bit and bring down the Z-axis until it's actually crashing into the bed, click, right there went the limit switch, so it would stop it from going any further than there. That's how you want it adjusted. You might be able to hear that click. So you want it adjusted so it's not clicking when it's in the home position. So now that it's all wired up, through a bit of trial and error and me having to go back through a couple times and redo a few more things inside all the looms, let me give you a quick rundown of where everything goes. These two ribbon cables from the controller come down here. I've got them coiled up, folded over on themselves, and attached to this rail along with this limit switch right here that goes all the way over here. That's the one for the X-axis. Well, that lead comes up like this, goes over the top, and I've got it wire tied to a little electrical terminal that I stuck on one of the bolts there, something to just keep it from moving around and catching on this if it goes down, up, whatever. So those come down that rail along with this whole umbilical, and we put a few wire ties around there to hold them in place, and they all end up terminating down here on the main board. When you look at the wiring diagram that we looked at earlier, it'll tell you where all those things go, but right now what I want to do is just go over where I've routed things. Now this umbilical right here that goes up and over the top and back down to the print head, that carries the wires for this fan, for this stepper motor, for this proximity sensor, and for the print head. You know, the print head wire, it's important to keep that up out of the way off the bed. So I've got it bent a little bit right here and pulled up, and then it goes through a little cable holder that I put on here. It's just a little plastic cable holder. Didn't come with the kit. This is something I added, and I put it on here. I put a screw in there in the place of one of the Allen bolts to hold that in place. It does a nice job of keeping that all in place. And then where the thing V's off into two sections, I put a little electrical tape on there just to keep it a little bit nice and neat. Over here on the bed, we've got some leads. This is just basically, like I mentioned earlier, a computer power supply connector. We got two red wires, two black wires, and two yellow. All run through this loom and come up here and plug into the main board. And the one for the stepper motor here for the X-axis, because it has to move up and down, I've got this just folded over on itself like a ribbon, so it can give and take a little bit. And then I just took everything right here and put a wire tie around it to snug it all up nice and tight, keep everything nice and tidy. There's a bunch of extra wire for that limit switch for the Z-axis. I just folded it over on itself and bundled it up and made a nice neat little bundle of it there. And that's about it. That's how the wiring is routed. Oh yeah, one more thing. The power supply wire runs across the back, and I just put it right in the channel here and then runs over to there. And then I put two little pieces of plastic that I had that I just stuck in the ends here. You can see, you just cut them the right width, and you just slide them in there and they hold the wire in place for you. Okay, so we're ready to print, so let's go in here to the control menu and let's set some temperatures ahead of time. Let's put the nozzle at about 210. This is all Celsius, by the way. 210 seems to be a pretty common number to run it at. We may not be able to toggle it exactly to 210, 212, close enough. Let's put the bed at about 90. And we'll leave the fan speed alone for now. Let's go back up to the, let's see, this screen. Let's go to prepare, and then we'll go to preheat PLA. Hit the preheat PLA button, and it's going to start warming things up for us. So we're warming up now. We're warmed up to the point where we can load up some PLA into the print head. I've cut off the PLA to a nice blunt edge. Now if you push on the back portion of the print head here where it feeds, this will push up and down, and what it does is it releases it from the gear. Then you can push your PLA in there, push that down, shove it in till it goes all the way through, and then you push it through till it extrudes a little. Now when I push down on the release button and push on the PLA, you see how it's coming out. So that's good. We'll let go of everything now, and we are pretty much ready to print. Now I've got a program open that came with the 3D printer. It's called Cura. This is version 15.04.6, and this is where you open up your 3D programs. This is a one called a fish that I got from Thingiverse, and in here is where you can set all the settings for the temperature, etc., and they will be set into the G code, and then you'll save it. Once you get it all the way you like it, you will do a save G code, and then you save it into a folder, and there it is, the fish fossil G code. I already did it. So once you do that, then you can transfer it to an SD card. I have one of those right here. I've already transferred it to the SD card. We'll load that into the control board on the printer, and we'll print from that. So back to the control board. Let's put the card in, and we're going to go to the menu here, and we should have print from SD card. We'll click on that, and there's a few files on here. Let's find our fish code. Let's see, I've got one. There it is. Push that, and you'll see it says bed heating. Once everything is heated up where it's supposed to be, it will start to print. The bed got up to temperature, and the program kicked in and started printing. Our little fish is being printed. And there it is. It's all articulated cool. I've got another one printing too. It's so cool, I decided to print one more. Wow, that's pretty neat. You can get some pretty neat articulation out of 3D printing. Stuff can be printed because of the layer effect. You can do things that interjoin with each other and still remain independent, like this here little fishy. All done! I got a 3D printer that's working, and I can't wait to start using it, especially for the circuit design thing I was talking about. That's going to be coming up pretty soon, and I'm really excited about that. I've got a reflow soldering hot air tool to work with to do some of that stuff, but we'll get to that later. In the meantime, I've got this now as a handy tool to do all kinds of things with, and when you get one, all of a sudden all these ideas come to you of what you can really use it for. Initially I didn't really think I would be using it for a lot, but it really changes the way you think about putting things together and inventing and hacking stuff. So thanks for watching. Thanks for all the donations, and be sure to like and share. Follow me on Twitter, Instagram, and Facebook, and until next time. That's a neat thing you can do with 3D printing. Oops, get back here, little fishy.